Okay, so let's continue with IP Infusion notes for white box, SDN, and NFV solutions. I think we've heard a lot about hardware. Somebody said that software has become, very important for the next generation solutions. Let's see a little bit more about that. So let's take a look first of all at the traditional SDN architecture, NFV and white box, and what are the basic principles that they have introduced into their network. Starting with the SDN architecture, one of the main parts, as we probably all of us know, is to be open, to have open programmable APIs at different layers, whether it is control plane, whether it is management plane. And another important aspect of the SDN was the separation between the control plane and the underlying data plane. So having a simple switch to do forwarding of packets and then offloading the whole intelligence into one single entity, which is the controller, right? We can think of additional, additional principles within the SDN architecture, but I believe these two capture a lot about that. NFV architecture, the software is center stage, and along with virtualization, approaching the networking solutions differently, using servers to do even 1 gig, 10 gig, 40 gig networking functions. And last but not least, white box. White box has evolved into my understanding as a side effect of the SDN architecture. So again, we see the need for open and programmable APIs, and of course, a separation between the hardware and the software. And this kind of separation gives a flexibility to the end customers to select hardware and software from different sources, and so the networking solution becomes more flexible, more independent. Let's see a little bit more about the challenges that those three kind of architectures and approaches have brought along. Starting with the SDN, one of the issues that many people are facing is scalability, whether it comes at the controller side or whether it comes at the data plane side, with flow table size, with the TICA memory, and so on. Interoperability is another issue that we are facing to some extent with SDN solutions. NFV, in some cases performance, and of course when it comes to different types of interfaces, where there's 1 gig, 10 gig, 40 gig, and using the right card brings along some issues. And with white box, this is the area where we see the demand for deploying white box into all kinds of network. But then we realize that, do we have the right full feature set to approach that? Do we have the needed carrier grade performance to be more successful? And of course, at the end, which is very important for data centers, but also telco customers, is the support, the maturity, and the stability of the complete ecosystem that the white box solution brings along. So having all this kind of architectures and challenges in mind, we from IP Infusion, we thought that we are in a position to address these new needs and challenges of the market, because we have all the ingredients in place. We just need to package them correctly and offer that to the end customers, and provide something that makes sense in both areas, both white box and NFV. So almost 2 years ago, we introduced OCNOS, Open Compute Networking Operating System, to provide a solution for white boxes which can address the data center, but also the telco and the carrier business, right? And in addition to that, we also have Virnos, which is a pure NFV solution, and can be deployed in different types of applications, whether it is a CPE, a router effector, and we will see more about that. And both solutions offer the management plane that is up to that level with advanced framework, our own solution, including NetConf and other features. So that gives you a little bit overview about how we are trying to address these new areas in terms of white boxes and NFV. Now, looking at the benefits is to some extent the answer to the challenges I mentioned before, where somebody who is looking for a white box solution is looking for something that is a solution and not just one or two features, whether it is a VLAN feature or just VXLAN or maybe layer 3. Typically, most of the customers want something that works now, but also gives the flexibility to enhance that if there is a need. So IP Infusion offers a full feature set solution that addresses layer 2, layer 3, and MPLS. And that makes a difference. In addition to that, it is a carrier-grade solution that has been tested over the course of many years in the past, and in different kinds of networks. So we have the scalability and high performance that is required to address these requirements. And of course, which is important for many big customers, whether it is data center or telco, is a seamless integration, which enables them, to lower the risk and lower the effort moving from the traditional networking into this disaggregated. Let's look about OCNOS, how it is built, what are the important components, and why does it really make a difference as opposed to some of our competitors or traditional solutions we find with the usual system vendors. So we have actually architecture that sits on top of traditional switch, whether it is Broadcom or could be also Marvell. In these cases, we're seeing different ODM vendors, one of which is, of course, Agima. And on top of that, we have a complete solution, control plane, management plane, and the integration into the chipset for forwarding. And we bundle that, and we offer that as a, bootable image on different kinds of switches. What is important is, of course, the ingredients that we have within our solution and make a difference for our customers, right? And the ingredients is quite important because enables IP Infusion to compete at different levels with customers, with competitors for our end customers. So looking at the ingredients, we have our ZEBOS, which is the heart of the system, which is a control plane. It's a protocol stack that has been sold over 300 customers worldwide for the 15 years, and has been deployed in different kinds of applications, whether it is data center, whether it is telco, whether it is satellite communication. So essentially every device that has a need for a networking feature, ZEBOS has been a very reliable solution. And along with that, we have our own management plane, which is used. And very important, the integration onto the silicon. As a matter of fact, This kind of separation between control plane and here data plane was part of our solution since 2000. So again, this is a proof of our SDN approach, if you want, where abstraction between control plane and underlying data plane has been right from the beginning. And that gave the flexibility to many of our customers to deploy ZBOS into their own system solution. An overview about the platforms that we support for different ODMs, and mainly we are focused on Broadcom, but we have discussions with Marvell, we have discussions with Mellanox, and Intel and other chipset providers to have the flexibility to support OCNOS on their hardware platform. Again, solutions, we would like to approach both data center, interconnect, whether it is layer 2 or layer 3, and also service providers. So these are the 3 areas that we focus. We have examples of OCNOS deployment. We have examples of big POCs that we are doing right now. We see a lot of interest. And we believe that all of those 3 can be a very good area where OCNOS can be deployed. As I mentioned before, the core of the heart of the system is our control plane. It's the protocols that have a unique architecture where almost every protocol runs as a separate Linux process. And essentially, many of our competitors are based essentially using the same open source that came from ZBOS and then evolved into Zebra and Quagga. Management plane. This is something that also gives a unique advantage to many of our customers because besides CLI and SNMP, they have a need for transactional-based management and the ability to put on top of our infrastructure different management protocols. So besides CLI and SNMP, we have support for netconf. We see a lot of interest for supporting netconf, and this is something that we will see that will become even stronger in terms of deployment. So another interesting roadmap thing is that we plan to do an integration with the Open Daylight controller. Again, starting with a netconf client that will talk to our switch, and especially for network topology and discovery and pushing the configuration to a network client from the controller. That is one interesting scenario that we plan to introduce in later on this year. With respect to integration on Agima, we have a long list of switches that we support from traditional Broadcom Strata XGS with 10 gig, 40 gig, and 100 gig. This new platform based on the Broadcom Qumran looks to be very interesting for many telco customers. And just want to give you a brief overview about what is currently happening with respect to the feature set. So we plan to have a very interesting release mid of this year, and supporting quality of services, and besides layer 2 and layer 3, also MPLS features, as you see here, layer 2, layer 3 VPNs, MPLS OEM, and also external pickup memory that enables us to scale above 700,000 routes. That is a quite interesting implementation, and that is something that can be tested from June 15th. Of course, right now we support layer 2 and layer 3, so if there is a need or interest to test this platform, you can talk to Agima to get the hardware, and from us you can get the software. Let's look at some use cases that, I mean, we can talk about more use cases, but one use case is utilizing layer 3 solution in typical leaf and spiral closed architecture. So we have here a core tier 1 routers. We have the spines and here the top of rack switches. And one approach is to use a pure layer 3 design for many reasons. For simplifying the solution, for using a non-blocking infrastructure, and maximizing the performance. In this case, based on our solution, you can use BGP as a layer 3 protocol, and netconf from a management perspective to automate the configuration of the individual devices. So in this case, what the situation would look like is you have autonomous system, same autonomous system for the core routers you have for the spines, the same autonomous system, and then every top of rack switch will have his own autonomous system number. And this is one way to set up the topology. And then use configuration and push that through netconf to each device. So that's something that can work now, and you can test it in your network based on different types of our switches, whether it is 10 gig, 40 gig, or 100 gig. Same with that. Let's look at our NFV solution, which we call Vernos. So here again, we use the same control plane as with Oknos, our own protocols for layer 2, layer 3, and MPLS. We developed our own data plane based on the InterDPDK framework and provide a solution based on WindRiver Linux that comes as a virtual machine and can support 1 gig or 10 gig interfaces at wire speed. So this is a very interesting solution for customers who want to complement their infrastructure with an NFV solution and use the single look and feel for both white boxes and NFV. This is one interesting scenario. Of course, different applications where it can be used as a VCB, can be used as a PE router, or a VPN IPsec. Also in the service provider, like a BGP route reflector, supporting full internet table, can also use as a peering device, and supports open flow and flow-based forwarding as well. In addition to that, we have integration with OpenStack for specific use cases, and also with Ansible. And with that, I would like to thank you. If there are any questions, I'm happy to answer now or maybe afterwards during the networking session.
Any questions? Okay, thank you.